A while ago, I was on the beach in Florida, and after a full day of laying on the beach, I got burned. Badly. It got me thinking, where is it easiest to get a sunburn? Today I present to you how to get a sunburn in 30 seconds or less. The sun emits all different lights on the electromagnetic spectrum, from radio waves to microwaves to infrared, and then to all the visible light we can see. But the light we care about is ultraviolet, because that's what causes sunburns, specifically UVA, B, and C. As UV light hits the skin, special cells called melanocytes release melanin. When the melanin is released, it causes your skin to become a darker color, and that's what makes you tan. But when there's too much UV light, the melanin can't handle it, and it creates what's called a free radical. The free radical goes around and it actually damages DNA, and the resulting inflammation and pain is what we call a sunburn. That was a really oversimplified view of what happens. I'll link to this video by Grow Science that does a much better job explaining. That was a vastly oversimplified view of what happens, but the general idea is clear. Too much UV equals sunburn. As mentioned before, there's 3 bands of UV radiation, UVA, B, and C. UVA is the most common and least harmful. UVB is in the middle. UVC is far more dangerous, but as you can see on this chart from Wikipedia, it's almost all of it gets filtered out by the ozone layer, which is represented by that yellow sideways curve. The next thing we need to look at is the UV index. The UV index is a tool created by 2 Canadian scientists in the 70s. It is a scale that estimates the level of UV exposure at a certain place at a certain time. It's a linear scale starting at 0, or darkness. A typical scale ends at 11 plus, with the warning that time spent outdoors should be limited. If you want to learn how to calculate the UV index, all you have to do is take a look at this really simple document. I will actually provide the link if any of you want to look at it. That document is pretty dense, so I'll walk you through the basics. First, some satellite measures are taken, which get the total level of solar irradiance, which means how much light is hitting the Earth. Then, some more satellite measures are taken of atmospheric thickness and other factors that might contribute to UV light blockage. Using the satellite data, a strength measure is given for each of the 3 UV bands. For each band, a weight is assigned. The weight corresponds to how harmful that band is to human skin. Once we have the weight, we multiply them together, and that gives us the weighted total. Now that we have the weighted totals for each band, we simply add them together, giving us a total weighted score. Now that we have a total weighted score, we have to adjust for elevation and cloud cover. For our sake, we'll just assume that we're at sea level and it's a perfectly sunny day. Now that we have our adjusted total, we divide by 25. Then we round to the nearest whole number, and that is our UV index. Let's look at where UV indexes are generally the highest. The first criteria is desert. The second one is high altitude, and the third one is the tropics. Keeping these criteria in mind, I've found 5 major semi-tropical deserts, some with high altitude, some without. The first one is the Sahara. Then we have the Kalahari, the Arabian, the Australian, and the Atacama deserts. The Sahara Desert is huge, but it only averages about 3,000 feet above sea level, which isn't particularly high. It does contain Mount Imi Koussi in Chad, with an elevation of 11,204 feet or 3,415 meters, making it a serious contender. Next we have the Kalahari Desert, which shares a similar elevation as the Sahara since they're both on the African plateau. However, there's no big mountainous areas in the Kalahari, which kinda eliminates it from contention. Our next desert is the Arabian Desert. It too isn't particularly high, but it does have some mountainous outcroppings. Specifically, Mount Al-Nabi Shu'ab, and it stands at 12,000 feet, or 3,666 meters tall. The next desert on our list is the Australian Desert. The Australian Desert is our lowest elevation desert on the whole list, with no major mountains. However, it does have the ozone hole, which means it gets far more UV radiation than you'd otherwise think. The final desert on our list is the Atacama Desert. It's known for being the driest place in the world, and it's also incredibly high altitude, with much of it existing at over 10,000 feet. It's also home to some peaks that can reach a staggering 20,000 feet, or 6,000 meters, making it extremely high elevation. Keeping all that in mind, I think it's clear that the Atacama is our #1 contender. All you have to do is Google Atacama UV index and you'll see results like this one that says that it can easily hit 20. By my calculations, that's a sunburn in under a minute, but we promised 30 seconds or less. Let's look at a UV map for December 29th, 2003. As you can see, the brighter red areas are all in the tropical latitudes, and there's some hot spots in the Kalahari, the Atacama, and Australia. If we zoom in though, you can see that the brightest parts are definitely in the Atacama Desert, right in the Chile, Argentina, and Bolivia border regions. And right under that hotspot on the Chilean-Bolivian border is the Licancabur volcano. That day, on top of the volcano, at nearly 20,000 feet, an absolutely astonishing UV index of 43 was recorded. That's over 4 times higher than what most scales consider extreme and limit your time outdoors. So how fast would it take you to get a sunburn with a UV index of 43? It's impossible to say, just due to the different rate at which individual skin burns, but there are a few estimates we can make. My most conservative estimate was that a person would burn in 45 seconds, and my most aggressive estimate was that a person would burn in under 2 seconds. So I think it's safe to say it qualifies as 30 seconds or less. When the UV index hit 43 on Licancabur, it was really the perfect storm for UV radiation. The first factor, it's in a desert, like we already talked about. The second factor is it sits at a tropical latitude, just barely, but it is technically within the tropics, at 20 degrees south. The next major factor to talk about is the elevation. As we discussed, it's nearly 20,000 feet, making it incredibly high. The next important thing to consider is the date. As you can see from this little animation, the sun is almost directly overhead on the 29th of December, which is when this happened. But all these factors happen every single year, so what was it about 2003 that made it so much stronger? Well, the first thing was the ozone hole that we talked about earlier had shifted and was actually over the Atacama Desert at the time, making there even less resistance than there usually is. Then the last thing was there was a week earlier a huge solar storm which potentially damaged the atmosphere and its ozone layer even more than usual, causing an extreme amount of UV radiation. We likely would not even have known about this, but there was a NASA expedition going on in the area looking for places most similar to the surface of Mars for an upcoming rover landing. The high UV reading was initially written off as an instrument error, but later it was confirmed with other similar high readings from different instruments. If you want to get a sunburn in less than 30 seconds, first you have to travel back in time to December 29th, 2003, then you have to travel and then climb Licancabur volcano on the border of Chile and Bolivia, and then you have to go sunbathing. I guess if you really wanted to though, you could probably just try arc welding without the proper safety equipment. That'll usually do the trick. Thanks for watching everyone. This was a little experiment. I'm sure there's a lot of improvements I can make, but I'd like to keep doing these videos, and remember to wear your sunscreen.